Hi, my name is Muhammad Rian bin Muhammad Rafi, admin number 2402361F, and today I'm going to show you how to find the approximate solution of an IVP using the Euler method.
So how we use the Euler method is we use it to find the solution of y at any given point of x. For example, here x is 1 and we want to find the solution of y. So I've drawn a graph and I've drawn a list to show you how I derive the formula, which is this, and I will explain it now. So first up, we draw a tangent line against the initial point, which is x0 and y0 over here. Draw a tangent line. And looking over at the list, how I get from x0 to x1 is that I added x0 with h, which is the step size. The step size is the equal intervals between the x-axis. So this is equal, they are called the step size. Now I get from y0 to y1 is more trickier. So how I derive the formula is, we already know the value of y0, so we just add it into the solution, and then we want to find the question mark over here. And how do we do that? It's very simple. So we can agree that the solution of function at x0 and y0 is the same as the rise over run for question mark and h. So what I did was multiply h on both sides and I got this, and this is the value of the question mark, and then the question mark is added on to the y0 value, and that is how I derive the formula here. Same thing here, but the catch is that we have to use the previous value of y. Same as here, I have to use the previous value of x. And then yeah, that is how I derive the formula of the Euler method.
In the demo, I want to show you how to use the Euler formula on this differential equation, x to the power of 2 plus 1 over y. And I determine the step size as 0.1 because the smaller the step size is, the smaller the approximation error will be. So the initial value is 0 and 1 for x and y, and you want to find out y when x is equal to 0.5. So I created 3 columns, n, xn, and yn, and just counting out 0, 1, 2, 3, 4, 5. This is x0 and y0. So x0 is the formula I put the previous value plus the step size. Same as here, the previous value plus the step size for b4, b3 plus 0.1, for b5, b4 plus 0.1, and so on. For yn, I put the formula, the Euler formula inside. So as you all know, the formula is y0 plus h times the differential equation, but I sub in the values of x0 and y0 inside. Same as here, the previous values of x1 and y1 inside the Euler method, Euler formula. Same as here, and same as here. So that is how I do the Euler formula. I went on to add on a few more cells just to solve for y when x is equal to 1. So y is 0, 1.911375 using the Euler method. And I use the same formula for the values that are in the previous row. And the actual value I already calculated is 1.9061. And that is very close to the actual value. The approximation is very close to the actual value. So the approximation error is 0.0053, which is less than a 5% relative error. And that is how reliable the Euler method is. It is it's like very accurate, but not really the actual value, but it's a very accurate approximation of the actual value. So that's how you find an approximate solution of an IVP using the Euler method. My name is Muhammad Rian bin Muhammad Rafi, admin number 2402361F, and thank you and bye bye.